When we look up at the night sky, we see countless stars shimmering against the vast darkness, each one holding the possibility of planets circling around it. Some of these planets are rocky like Earth, some are gaseous like Jupiter, and others defy imagination with their bizarre and hostile conditions. Among these worlds, there is one that stands out not only for its beauty but for its terrifying environment, HD 189,733b, a planet that has captured the fascination of astronomers and the imagination of dreamers. This alien world, over 60 light-years away in the constellation Vulpecula, looks calm and blue from afar, resembling our Earth, but this resemblance is deceptive. Behind its tranquil, sapphire appearance lies one of the most dangerous environments ever discovered, a place where storms rage with unimaginable fury and where the rain is not water but glass, blown sideways at thousands of miles per hour. To understand why this planet is so hostile, we first need to imagine its scale and position in the universe. HD 189,733b is what scientists call a hot Jupiter, a gas giant similar in size to Jupiter but orbiting incredibly close to its star. In fact, it circles its parent star in just over 2 days, meaning its year is shorter than a week on Earth. This proximity has a dramatic effect on the planet's climate. The side facing the star is blasted with constant, scorching radiation, while the opposite side is plunged into eternal darkness. Unlike Earth, which rotates and distributes its warmth through seasons and weather systems, HD 189,733b is tidally locked, which means one side always faces its sun while the other remains in night. The result is a world torn between two extremes, with forces of heat and cold colliding in violent atmospheric battles. The winds on this planet are not just breezes or storms as we know them. They reach speeds of over 5,000 miles per hour, faster than the speed of sound, faster than the bullets we fire from rifles, faster than anything we could possibly imagine standing against. Imagine the most powerful hurricane on Earth, which may reach winds of 200 miles per hour, and then multiply that speed by 25. These winds whip across the planet, carrying with them particles of vaporized rock that condense in the cooler atmosphere. But what condenses here is not water like on Earth. Instead, it is silicate, the same material that makes up glass. And when these silicate particles form droplets, they fall as rain, only to be caught by the ferocious winds and hurled sideways like shards of shattered windows carried in an endless storm. Now, picture yourself standing in this environment, not that any human could. The sky, rather than blue from oxygen like on Earth, appears blue because of the way silicate particles scatter light. At first glance, it would be breathtaking, a jewel shimmering in space, a world that looks like a beautiful ocean planet. But beauty here is fatal. The very atmosphere is poison, composed of gases no human lungs could breathe at temperatures so high they could scorch flesh instantly. The winds would tear apart any spacecraft that tried to enter, shredding metal and glass alike. If by some miracle you survived the heat and the winds, the rain itself would end you. The glass would slice through any protection we know how to build. It would be like standing inside a giant sandblaster, except instead of sand, it is shards of deadly crystal. The discovery of HD 189,733b and its strange weather did not come easily. Astronomers detected it by watching the dimming of its star as the planet passed in front, a method known as the transit technique. With powerful telescopes, they were able to study the starlight passing through its atmosphere and found evidence of the silicate particles that give rise to the glass rain. This was one of the first times we could peer into the atmosphere of a planet so far away, and what we found astonished even the most seasoned scientists. The universe, it seemed, was capable of creating worlds far stranger and far more dangerous than anything we had ever seen in our own solar system. But why does glass rain here in the first place? On Earth, our rain cycle depends on the evaporation of water from oceans, lakes, and rivers, which then condenses into droplets and falls back to the ground. On HD 189,733b, the high temperatures and pressures cause silicate compounds to vaporize into the atmosphere. As these vapors cool in the upper layers, they condense into tiny glass particles. Gravity pulls them down just like raindrops, but instead of a gentle patter, they are immediately swept up by the supersonic winds and blasted sideways in storms that encircle the planet. The very concept challenges our imagination. It forces us to accept that weather, something we think of as familiar, can take forms so alien that it almost sounds like a scene from science fiction. The conditions here make us reflect on the resilience and fragility of life. Earth has weather too, sometimes violent hurricanes, tornadoes, or blizzards, but these extremes are survivable. They shape our landscapes and ecosystems, yet life adapts and thrives. On HD 189,733b, adaptation would be impossible. There could be no fragile plants putting down roots, no animals finding shelter, no humans setting up colonies. It is a planet that repels life at every level, a world designed to be deadly. Its existence reminds us that not every planet in the universe is a potential home. While some dreamers talk about colonizing Mars or searching for Earth-like planets, we must remember that most worlds are not like ours. They are harsh, hostile, and merciless, and HD 189,733b is the epitome of that hostility. Still, there is something profoundly humbling about such a discovery. From Earth, the planet appears as a distant dot, a faint whisper of light against the backdrop of the cosmos. We might look at it and think of oceans, skies, and calm days. Yet the truth is so different. It is as if the universe is teaching us that appearances can deceive. What looks calm and beautiful from afar can be wild and lethal up close. It is a lesson not only about astronomy but about life itself. Never take things at face value, for reality often hides beneath the surface. The study of such planets also expands our understanding of physics and atmospheric science. By examining the dynamics of HD 189,733b, scientists gain insights into how atmospheres behave under extreme conditions. The interaction of heat, pressure, and exotic chemistry there helps refine our models of planetary weather. It teaches us how planets form, evolve, and sometimes self-destruct. In a way, HD 189,733b is a laboratory in the sky, one that shows us the extremes of what is possible in the universe. Its deadly storms become data points, its hostile winds become lessons, and its glass rain becomes evidence of just how creative nature can be in shaping worlds. For storytellers and visionaries, this planet ignites the imagination. Writers have long dreamed of alien worlds where strange substances fall from the sky, diamonds, acid, or fire. Here, we see that reality has already surpassed fiction. HD 189,733b is proof that the universe is more creative than we are. It suggests that if glass can rain on one world, then somewhere else, diamonds may fall, or iron may drizzle like molten drops. Indeed, astronomers suspect that other exoplanets may have such bizarre weather. Each discovery pushes the boundary of our wonder and our fear. It also deepens our appreciation for Earth. Here, the rain that falls sustains life. It nourishes our crops, fills our rivers, and shapes our landscapes. Here, the winds, though sometimes fierce, carry seeds across fields and help balance temperatures across regions. Our weather, even at its harshest, is life-giving. When we compare it to the glass storms of HD 189,733b, we realize just how finely tuned our planet is. The balance of oxygen, nitrogen, water, and warmth creates an environment where life not only survives but flourishes. Against the backdrop of a cosmos filled with dangerous, alien storms, Earth shines as an oasis of calm. Perhaps the most striking thing about HD 189,733b is that despite all its hostility, it is still beautiful. Astronomers have often remarked that if we could see it with our eyes, it would appear a deep, stunning blue, richer than any ocean. There is something haunting in that beauty. It is a world that reminds us of a sapphire, shining brightly in the darkness, yet sharp enough to cut. There is poetry in its existence, a paradox of elegance and destruction. It symbolizes the duality of the universe. That which attracts us can also harm us. That which seems serene can conceal unimaginable power. One can imagine, centuries from now, explorers gazing at HD 189,733b through the windows of powerful telescopes or even distant probes. They may marvel at the sight, knowing well that they can never land there, never walk its surface, never call it home, and yet they will feel awe, because sometimes exploration is not about conquering or settling. Sometimes it is about witnessing, about respecting the raw power of nature and accepting that some places are not meant for us. In the end, HD 189,733b is more than a planet. It is a symbol of the universe's creativity and danger. It is a reminder that beauty and danger often coexist, that not everything shining in the distance is meant to be touched. It challenges us to expand our minds, to accept that the cosmos is filled with realities stranger than fiction, and to cherish the small blue dot we call Earth. Because while glass rains sideways on that faraway world here, water falls gently from the sky, feeding rivers, quenching thirst, and giving life. That contrast is the greatest lesson of all, that in the midst of a universe full of deadly storms, our home is the rare shelter where life has found its sanctuary. When we think of planets, we usually imagine rocky worlds like Earth or Mars, or gas giants like Jupiter and Saturn. Some of us even picture distant exoplanets that may have oceans, continents, or alien skies. But the truth is, the cosmos is filled with worlds that defy imagination, where the conditions are so violent and so unforgiving that they remind us how fragile life is. Among these worlds, one of the most terrifying is Kelt 9b, a planet so hot that it challenges the very definition of what a planet can be. Its atmosphere is a furnace, its orbit a death trap, and its future uncertain. If HD 189,733b dazzled us with glass rain, then Kelt 9b scorches our imagination with temperatures hotter than many stars. Discovered in 2016, Kelt 9b lies about 650 light-years away in the constellation Cygnus. It belongs to a class of planets known as ultra-hot Jupiters, massive gas giants that orbit extremely close to their parent stars. But even among ultra-hot Jupiters, Kelt 9b is extraordinary. Its size is more than twice that of Jupiter, yet it is lighter, puffed up like a balloon because of the immense heat blasting through its atmosphere. And when we say heat, we are not talking about a warm summer day or even the blistering surface of Venus. We are talking about temperatures exceeding 40,000 degrees Celsius, hotter than many small stars. To put this in perspective, metals like iron or titanium would not only melt but actually vaporize in such conditions. Molecules cannot survive in this searing environment. They are ripped apart into their constituent atoms, creating an atmosphere more like a stellar corona than a planetary sky. What makes this planet so extreme is its proximity to its star. Kelt 9b orbits its parent star, Kelt 9, at a distance so small that it completes a full revolution in just 1.5 Earth days. Imagine a year lasting only 36 hours. The star itself is an enormous, bright A-type star, much hotter and larger than our Sun. Being chained so close to such a stellar giant means the planet is continuously bathed in radiation, thousands of times more intense than what Earth receives. The heat is relentless, unending, and inescapable. Unlike Earth, where day turns to night and seasons offer cycles of relief, Kelt 9b is tidally locked. One hemisphere faces its star permanently, cooking under eternal daylight, while the other side is trapped in permanent night. But the winds that roar across the planet carry scorching gases from the day side to the night side, ensuring that even the dark hemisphere is unbearably hot. It is almost impossible for us to picture what such a world would be like. If standing were possible, on the day side you would be instantly vaporized. The heat would not simply burn flesh or melt metal, it would tear apart the very atoms of any material. A spacecraft approaching the planet would find itself overwhelmed by radiation long before it reached the atmosphere. Protective shielding would fail, electronics would fry. The idea of surviving there is absurd. Even our most heat-resistant materials could not last. We designed spacecraft to survive the cold of deep space, the radiation of Jupiter, or the heat of re-entry into Earth's atmosphere, but nothing we know of can endure the fury of Kelt 9b. The atmosphere of this world is equally alien because of the heat. Hydrogen, the simplest and most abundant element, dominates while heavier molecules cannot remain intact. Metals like iron and titanium exist not as solids or liquids, but as gases, drifting like steam across the skies. The planet's atmosphere glows faintly, as if lit from within, shimmering with the radiation of its tortured atoms. Some astronomers describe it as more star-like than planet-like, a bizarre hybrid between a world and a sun. When researchers studied its spectrum, they found traces of ionized metals, something no one expected to find in a planetary atmosphere. It is as if the boundary between planet and star begins to blur here. Over time, this extreme environment is taking its toll. Kelt 9b is slowly being destroyed by its parent star. The intense radiation is stripping away its atmosphere, blasting gases into space like steam rising from boiling water. Streams of hydrogen and helium trail behind it, forming a kind of comet-like tail that stretches into the void. If the process continues, the planet could eventually lose much of its mass or even disintegrate entirely. Some scientists speculate that one day Kelt 9b might shrink, leaving behind only a rocky core, or perhaps be consumed altogether by its star. In this sense, the planet is not just dangerous, it is doomed. Its very existence is a temporary stage in a cosmic tragedy, a reminder that planets can die just as stars can. The discovery of Kelt 9b pushed the boundaries of our knowledge. For decades, scientists imagined planets as either rocky worlds like Earth or gas giants like Jupiter and Saturn. The idea of a planet hotter than a star's surface seemed almost absurd, and yet here it was, blazing like a furnace, mocking our limited imagination. Observations of Kelt 9b revealed that our universe does not conform to our expectations. Instead, it constantly surprises us, constantly reveals possibilities stranger than we thought possible. The planet became a test case for new theories about atmospheric chemistry, planetary evolution, and the delicate balance between stars and their companions. From a poetic perspective, Kelt 9b also challenges how we think about beauty. Imagine looking at it through a telescope. Its star burns brilliantly, and close to it, this swollen, glowing planet orbits in a tight embrace. The sight would be spectacular, yet deadly. The colors of its atmosphere, the shimmering metals, the fiery winds, would make it appear like a jewel on fire. It would be breathtaking to see but impossible to approach. In that contradiction lies its haunting beauty, something that draws the eye but repels the body, something meant only to be admired from afar. If we think of weather on Earth, we imagine clouds, storms, and gentle rains. On Kelt 9b, weather is a cosmic inferno. Winds move gases from the blazing day side to the night side, but even the night side remains hotter than the hottest deserts on Earth. There are no clouds of water vapor here, no storms as we know them. Instead, the very atmosphere is alive with the motion of superheated gases, glowing faintly as radiation tears through them. The winds may reach thousands of miles per hour, but the concept of storms feels meaningless when everything is already boiling. This is not weather, it is chaos. The conditions on this planet force us to reconsider what habitability really means. We often talk about finding Earth-like planets, places with liquid water, breathable air, and moderate temperatures. Kelt 9b is the antithesis of habitability. It is as far from Earth-like as possible, a world that screams in opposition to life, and yet by studying it we learn more about the extremes of planetary science. We understand how atmospheres can behave under extraordinary heat. We learn how molecules break apart, how radiation reshapes matter, and how planets can be eroded by their stars. Every data point we gather from Kelt 9b enriches our understanding not only of alien worlds, but of our own. There is also something deeply symbolic about Kelt 9b's fate. Orbiting so close to its star, it is like a moth trapped in the flame, unable to escape the heat that destroys it. Its orbit is a prison, and its destiny is destruction. And yet it endures for now, glowing, surviving, holding itself together against the relentless assault of its star. Perhaps there is a lesson in that endurance. Even in the harshest conditions, even in the face of inevitable doom, the planet continues its path, orbit after orbit, year after year. It shows resilience not because it will survive forever, but because it survives at all. Comparing Kelt 9b to our solar system makes us appreciate our own place in the cosmos. Venus, with its 460 degrees Celsius surface, once seemed unbearably hostile. Yet next to Kelt 9b, Venus is almost temperate. Even Mercury, the closest planet to our Sun, does not reach temperatures anywhere near those of this ultra-hot Jupiter. Earth, by contrast, exists in a narrow zone where water can remain liquid, where air is breathable, where life can thrive. We orbit not too close and not too far, receiving just the right amount of energy. Kelt 9b, in its fiery dance, reminds us that such balance is rare, and that we are fortunate beyond measure to live on a planet that supports life. For storytellers, artists, and dreamers, Kelt 9b is a source of inspiration. It is a world that embodies extremes, a vision of fire and destruction that could populate myths or science fiction tales. Imagine civilizations living on moons orbiting it, watching their sky lit by the glow of this impossible planet. Imagine stories of gods and demons tied to its eternal fire. Though it cannot host life, it can host imagination. Its very existence enriches the canvas of human creativity, providing a stage on which our minds can paint tales of resilience, danger, and wonder. In the end, Kelt 9b is more than a scientific discovery. It is a reminder of the vast diversity of worlds that exist beyond our own. Some planets are calm and Earth, like others icy and distant, and others, like this one, blazing with impossible heat. Together, they form the orchestra of the cosmos, each world a different note, each orbit a rhythm in the endless song of the universe, and Kelt 9b, with its searing heat and tragic destiny, plays a note of fire, a reminder that the universe is both beautiful and brutal, wondrous and terrifying. We will never walk on Kelt 9b, we will never build cities there or sail its skies, but we can learn from it, admire it, and let it remind us of the fragile gift of Earth. Because in the vastness of space, where planets can burn hotter than stars or rain glass in eternal storms, our home remains the rare sanctuary, and perhaps that is the greatest lesson of Kelt 9b, that in a universe of extremes, balance is rare and life is precious. When we look up at the night sky and see Jupiter shining brightly, it appears as a beautiful beacon, a giant planet that has fascinated humans since ancient times. To the naked eye, it looks peaceful, almost like a star, glowing steadily in the darkness. Through a telescope, we see its colorful bands, its swirling storms, and its iconic great red spot. It looks majestic, almost inviting, like a world that might hold secrets worth exploring. Yet beneath this beauty lies one of the most dangerous and inhospitable places in our solar system. A world whose immense gravity, crushing pressure, and deadly radiation make it utterly hostile to life as we know it. Jupiter may be magnificent, but it is also merciless, a giant that hides lethal truths behind its stunning clouds. Jupiter is the largest planet in our solar system, more than 11 times wider than Earth, and more than 300 times more massive. It is made mostly of hydrogen and helium, the same elements that fuel our Sun, but it never grew large enough to ignite nuclear fusion and become a star. In many ways, Jupiter is a failed star, a colossal ball of gas held together by its own gravity. Its size alone makes it extraordinary, but its danger lies in the consequences of that size. Gravity on Jupiter is immense. If you could somehow stand on a solid surface there, though no true surface exists, you would feel a force 2.5 times stronger than Earth's gravity pulling you down. But the deeper you go, the stronger that gravity becomes, and the more intense the pressure grows. Unlike Earth, Jupiter has no solid ground. Its visible clouds are just the uppermost layers of an atmosphere that extends for thousands of kilometers. If a spacecraft were to descend into this atmosphere, it would first pass through layers of ammonia and water clouds, buffeted by violent winds. As it sank deeper, the pressures would increase rapidly, the temperature would rise, and the gases would become denser. Eventually, the atmosphere would thicken into a supercritical fluid, a strange state of matter that is neither gas nor liquid, but something in between. At greater depths still, hydrogen, under unimaginable pressure, would transform into metallic hydrogen, a substance that does not exist naturally on Earth. In this metallic form, hydrogen behaves like a liquid metal, capable of conducting electricity and generating Jupiter's powerful magnetic field. The journey downward would be impossible for any spacecraft we can build. Long before reaching the metallic hydrogen layer, the craft would be crushed by the pressure. To put this into perspective, the pressure at the bottom of Earth's deepest ocean trench, the Mariana Trench, is about 1/100 times atmospheric pressure at sea level. That is enough to crush submarines not built to withstand it, but in Jupiter's depths, pressures reach millions of times Earth's surface pressure. No material we know of could survive such force. Any probe sent there would be flattened long before reaching the core. It is a realm forever hidden, accessible only to our imagination and computer models. As if crushing pressure were not enough, Jupiter is also surrounded by one of the most dangerous radiation environments in the solar system. The planet's enormous magnetic field, generated by the swirling metallic hydrogen inside, is more than 20 times stronger than Earth's. This field traps charged particles from the solar wind, creating radiation belts around the planet far more intense than Earth's Van Allen belts. These belts are so deadly that they could fry electronics in minutes and kill a human being in moments. When spacecraft like the Galileo probe or the more recent Juno mission approached Jupiter, their instruments had to be carefully shielded, and even then, they could only survive limited exposure. The radiation is not just a minor inconvenience, it is a lethal barrier that makes prolonged exploration around Jupiter extremely challenging. The visible storms on Jupiter only add to its hostility. The Great Red Spot, a gigantic storm larger than Earth itself, has been raging for at least 400 years, possibly much longer. Winds in the storm reach speeds of hundreds of miles per hour, whipping clouds of ammonia and water into chaotic patterns. Elsewhere on the planet, jet streams tear across the atmosphere in alternating bands, creating the colorful stripes we see through telescopes. These storms are powered by the planet's internal heat, which radiates more energy into space than Jupiter receives from the Sun. In other words, the planet glows with its own energy, a restless giant that never calms. Any attempt to enter this atmosphere would be like flying into a hurricane that never ends, with no hope of escape. Despite these dangers, Jupiter is not just a threat, it is also a protector. Its massive gravity acts like a shield for Earth and the other inner planets, pulling in or deflecting comets and asteroids that might otherwise crash into us. Some scientists believe that without Jupiter, Earth might have been bombarded so heavily in its early history that life could never have emerged. In this sense, Jupiter is both a guardian and a destroyer, a planet whose influence extends across the solar system. Its danger is balanced by its role in preserving the fragile stability that allowed us to exist. Still, the fascination with Jupiter's danger is irresistible. Imagine a descent into its atmosphere. At first, the skies might look beautiful, filled with bands of white, orange, and brown clouds. Lightning bolts, 1,000 times more powerful than those on Earth, would flash across the sky, illuminating the turbulence. As you fall deeper, the sunlight would fade, replaced by a dim glow from the planet's own heat. The air would thicken, the pressure would build, and soon every bone in your body would feel the crushing force. Your lungs would collapse, your blood would boil from the heat, and your body would be pulverized by pressures millions of times stronger than anything on Earth. Long before reaching the metallic hydrogen layer, you would be nothing more than atoms scattered into the giant's atmosphere. And yet, despite knowing this, humans continue to dream of exploring Jupiter. The Juno spacecraft, launched in 2011, is currently orbiting the planet, sending back breathtaking images of its poles and clouds. Its instruments study the magnetic field, the gravity, and the atmosphere, seeking clues about the planet's interior. But even Juno cannot fly close for long. Its orbits are carefully designed to avoid the worst of the radiation, and its systems are heavily shielded. Still, engineers expect the spacecraft will eventually succumb to the planet's harsh environment. The very act of sending a probe there is a testament to human curiosity and courage. We want to know, even if knowing means risking our machines against impossible odds. What makes Jupiter so dangerous also makes it fascinating from a scientific perspective. Its immense pressure creates conditions that may exist in no other place we can study. Metallic hydrogen, for example, is a substance that physicists long to understand, but it cannot be produced in large amounts on Earth. By studying Jupiter, we gain insights into this exotic material and into the processes that drive planetary magnetism. Its radiation belts teach us about charged particle physics on a grand scale. Its storms reveal how atmospheres behave under extreme energy. Every hazard is also an opportunity to learn, every danger a doorway to knowledge. Comparing Jupiter to Earth reveals just how special our planet is. Here, pressure is gentle, radiation is mild, and storms, though sometimes destructive, are survivable. Here, we can live, breathe, and thrive. On Jupiter, every element of the environment is designed to destroy. Gravity pulls too strongly, pressure crushes too brutally, radiation blasts too powerfully, and storms rage too endlessly. By studying Jupiter, we are reminded of the delicate balance that makes Earth habitable. Our atmosphere, magnetic field, and weather patterns are not accidents. They are the rare conditions that allow life to exist in a universe where giants like Jupiter dominate. Jupiter also sparks the imagination in other ways. Science fiction has often portrayed it as a realm of danger and wonder, a planet that humans could never visit but might someday orbit or observe more closely. Writers have imagined floating cities in its upper atmosphere, suspended above the crushing depths, or daring explorers diving into its storms. While these visions are unlikely to become reality, they reflect a deep truth: Jupiter inspires awe. Its sheer size, its beauty, and its danger combine to create a planet that feels alive, a giant with a presence that demands respect. In the grand story of the solar system, Jupiter plays a central role. It shaped the orbits of other planets, influenced the formation of the asteroid belt, and continues to act as a gravitational anchor for countless objects. Without it, our solar system would look very different. But as much as it gives, it also threatens. Its radiation can destroy spacecraft, its pressure can crush any descent, and its gravity can hurl comets inward toward Earth. It is both a friend and an enemy, a planet of dual natures. Ultimately, Jupiter is a reminder of the power of nature. We humans often think of ourselves as masters of our world, capable of bending the environment to our will, but when we look at Jupiter, we are humbled. Here is a planet so massive, so violent, so deadly that all our technology would crumble before it. Here is a world that does not care about human ambition, a world that simply exists in its own vastness and fury. It teaches us humility, awe, and respect. When we see Jupiter glowing in the night sky, we see only its beauty, but knowing what lies beneath that beauty gives us a deeper understanding of the universe. It reminds us that not all planets are hospitable, not all worlds are kind. Some are guardians, some are destroyers, and some are both at once. Jupiter is such a world, magnificent and merciless, stunning and savage, a giant whose crushing pressure and deadly radiation mark it as one of the most dangerous planets in space. And yet, despite all this, we keep looking, keep studying, keep dreaming, because even danger has its lessons, and even giants have their truths. Venus has long been one of the most captivating objects in our night sky, glowing like a jewel just after sunset or before dawn. Ancient civilizations revered it, poets wrote about it, and astronomers called it Earth's twin because of its similar size, mass, and position in the solar system. But the truth about Venus is far from romantic or gentle. When spacecraft finally pierced its thick, mysterious clouds, the world that was revealed was not a paradise but a nightmare. It is one of the most dangerous planets in our solar system, a vision of what happens when a planet turns hostile to life. On the surface of Venus, beauty is replaced by brutality, and the conditions there tell a sobering story about how fragile habitability really is. To understand just how dangerous Venus is, one must first grasp the intensity of its atmosphere. From Earth, telescopes reveal a planet covered in brilliant golden, white clouds, but those clouds are not soft water vapor like ours. They are made of sulfuric acid, a toxic chemical that burns and corrodes. These clouds are so thick that sunlight struggles to penetrate them. In fact, Venus reflects about 70% of the sunlight that hits it, making it one of the brightest objects in the night sky. But beneath that dazzling glow lies a suffocating, crushing blanket of carbon dioxide that wraps the planet in a deadly grip. The atmospheric pressure on Venus is about 92 times greater than Earth's at sea level. To put that into perspective, standing on Venus is like diving nearly a kilometer under the ocean here on Earth. The weight of the air alone would crush the human body flat within moments. No spacesuit could withstand it, and no unprotected machine could last for long. For decades, scientists speculated about Venus's true conditions, but it wasn't until the Soviet Union's Venera missions in the 1970s and 80s that humanity got its first direct look. The spacecraft that managed to land on Venus survived for only a few minutes to a couple of hours before being destroyed. Cameras melted, electronics fried, and hulls crumpled under the pressure. Those missions were brief but revolutionary, giving us haunting photographs of a desolate surface littered with rocks, scorched soil, and a dim orange sky that looks nothing like the pale blue of Earth. As if the pressure weren't deadly enough, the temperature on Venus adds another layer of horror. The surface simmers at about 460 degrees Celsius, hot enough to melt lead, zinc, and tin. That temperature is consistent across the planet, both day and night, because the thick atmosphere traps heat so efficiently. This is the ultimate example of the greenhouse effect gone wild. On Earth, greenhouse gases like carbon dioxide and methane help regulate the climate, trapping enough warmth for life to flourish. But on Venus, the carbon dioxide levels are so extreme that they have created a runaway greenhouse effect. Heat from the sun gets in but cannot escape, building up endlessly until the planet became a giant oven. What makes Venus even more terrifying is that billions of years ago it may not have been so different from Earth. Some scientists believe Venus once had oceans, flowing water, and perhaps even conditions suitable for life. But as the sun grew brighter and the planet's volcanic activity pumped more carbon dioxide into the atmosphere, Venus lost control of its climate. The oceans evaporated, water vapor escaped into space, and carbon dioxide remained trapped. Without water to help absorb carbon dioxide and regulate the climate, the greenhouse effect spiraled out of control. What might once have been a habitable world became a furnace of death. This vision of Venus as a failed Earth is not just fascinating but deeply sobering, because it forces us to ask, could this happen here? Venus is a warning of what happens when a planet's delicate balance tips too far. On Venus, the toxic skies are not just hot but stormy. Winds in the upper atmosphere howl at over 300 kilometers per hour, faster than any hurricane on Earth. These winds circulate the planet in just a few days, whipping the sulfuric acid clouds into vast, swirling formations. Lightning has been detected there, illuminating the acidic storms with deadly flashes. Yet on the surface, the air is so dense and heavy that those upper winds are muted. If you were standing among the rocks of Venus's landscape, the air would feel eerily still, suffocatingly hot, and unbearably crushing. The surface itself is another layer of danger. Venus is covered in vast plains of volcanic rock, mountains taller than any on Earth, and canyons deeper than the Grand Canyon. Scientists believe that Venus has been shaped by catastrophic volcanic eruptions in its past, possibly resurfacing the planet in one massive geologic upheaval hundreds of millions of years ago. There are hints that volcanoes may still be active today, releasing heat and gases into the already toxic atmosphere. If true, that would make Venus not just a dead world, but one that is still alive with geologic fury. Even its rotation is strange and unsettling. Venus rotates backward compared to most planets, meaning that the sun rises in the west and sets in the east. It also rotates extremely slowly. One day on Venus is longer than its year. This bizarre motion adds to the planet's mystery and may contribute to its chaotic climate patterns. For humans, visiting Venus is nearly impossible with today's technology. Even the most advanced landers struggle to last longer than a couple of hours before being destroyed. Space agencies are now exploring the possibility of studying Venus from the air instead of the ground. Above the crushing atmosphere, about 50 kilometers high, conditions are less hostile. There, the pressure is similar to Earth's, and although the air is still toxic, the environment is less extreme. Some have even imagined floating cities in the Venusian skies where humans could live suspended above the inferno below. It may sound like science fiction, but it highlights the desperate measures required to survive on such a world. Venus challenges our imagination not only because of its dangers, but also because of what it reveals about planetary science. It shows us how two planets, born in the same solar system and shaped by similar forces, can diverge into completely different destinies. Earth became a cradle for life, while Venus became a cautionary tale of planetary disaster. Studying Venus helps us understand the thin line between habitability and ruin. It reminds us that the greenhouse effect is not just a theory, it is a powerful force that can determine the fate of entire worlds. In this way, Venus is not just a dangerous planet, it is a mirror reflecting what could go wrong here on Earth if we fail to take care of our own fragile climate. For astronomers searching for life beyond our solar system, Venus also plays a role. Exoplanets, planets orbiting other stars, are being discovered in the thousands. Many of them are rocky worlds similar in size to Earth and Venus. The question always arises, are they more like Earth or more like Venus? The danger of assuming a planet is habitable just because it looks like Earth from a distance is clear. Venus teaches us that a planet can be Earth-sized and Earth-like in many ways yet still be utterly hostile to life. When we look at Venus, we see more than just a hot, toxic world. We see a story of transformation, of how a planet that may have been habitable lost everything and became one of the most dangerous places in the solar system. It is both terrifying and fascinating. Terrifying because it shows the extremes nature can reach. Fascinating because it challenges us to learn, to explore, and to protect the rare conditions that make life possible here at home. Venus will continue to tempt our imagination. Its brilliance in the night sky ensures it cannot be ignored. Future missions from NASA, ESA, and other space agencies are being planned to study it more closely. Probes will measure its atmosphere, orbiters will scan its surface, and maybe one day aerial explorers will float in its skies. Each mission will be a step into danger, but also a step toward knowledge. The more we learn about Venus, the more we learn about ourselves. Its dangers are not obstacles, they are lessons, and in those lessons we find the wisdom to better appreciate Earth. In the grand scale of the cosmos, Venus is only one of many dangerous worlds. But it is unique because it sits right next door, visible every morning and evening, reminding us that paradise and disaster can exist side by side. While Venus blazes like a jewel in the sky, it hides the heart of a furnace. And perhaps that is why it captivates us so deeply. It is a reminder that not all beauty is safe and not all neighbors are friendly. Venus is our twin, yes, but it is a twin that chose a darker path. To explore Venus is to explore the edge of survival, the boundary where life cannot endure. It is one of the most dangerous planets not because of one single factor, but because of all of them together. The crushing pressure, the toxic atmosphere, the searing heat, the acid rain, the volcanic scars, and the relentless storms. Any one of those would make life impossible, but combined they create a world that is utterly unforgiving. And yet, even in its hostility, Venus serves a purpose. It challenges us, teaches us, and humbles us. It reminds us that the universe is not built for our comfort, that survival is a rare gift, and that Earth's balance is something we must treasure. Venus stands as a monument to danger, a glowing warning in the sky, whispering to us every evening and morning, "Do not take your home for granted." In the vastness of the universe, where billions of stars host countless planets, there exists one that captures both the terror and the fragility of cosmic existence, WASP-12b. This world, unlike the giants of our solar system or the inhospitable rocky neighbors we know, is a planet in the process of death. It is not merely dangerous because of its searing heat, its choking atmosphere, or its violent weather, but because its very existence is being stripped away by the merciless gravity of the star it orbits. To study WASP-12b is to witness the slow destruction of a world, a reminder that even planets are not eternal, that in the great cosmic dance, even entire worlds can be victims. Discovered in 2008, WASP-12b immediately astonished astronomers because of its peculiar properties. It is a hot Jupiter, a gas giant similar in size to our Jupiter but orbiting dangerously close to its parent star. So close, in fact, that its year, the time it takes to complete one orbit, is less than 24 hours. Imagine a planet circling its sun not in the leisurely 365 days we know on Earth, not even in the 88 days of Mercury, but in just one Earth day. Such proximity has consequences beyond imagination. The star bombards the planet with constant, overwhelming radiation and heat, raising its surface temperature to around 500 degrees Celsius. At such temperatures, molecules cannot remain stable. Metals like iron and titanium vaporize, clouds of exotic minerals may form, and the very chemistry of the atmosphere becomes alien to us. But heat is only one part of the horror story. The gravitational pull from the parent star is so immense that WASP-12b is being stretched, deformed, and ultimately torn apart. Most planets, including Earth, maintain a roughly spherical shape because their own gravity balances against external forces. But WASP-12b is not spherical. It has been pulled into an egg-like shape, its outer layers elongated toward its star. This stretching is not a subtle effect. It is a sign of gravitational domination, a planet no longer in control of its own structure. Material from its atmosphere is being pulled away, streaming into space, forming a trail of gas that surrounds the system like a faint, deadly halo. Astronomers estimate that WASP-12b may not survive more than another 10 million years before it is completely consumed. In cosmic time, that is nothing more than the blink of an eye. To imagine what it would be like to stand on such a world, if that were even possible, is to step into a vision of doom. The sky would be dominated not by a distant, comforting star, but by an enormous, blazing sun filling half the horizon. The heat would be so intense that no solid ground could exist. The planet is gaseous, its atmosphere a thick soup of hydrogen and helium mixed with vaporized metals and exotic molecules. Any craft attempting to enter would be torn apart by radiation, fried by heat, and shredded by atmospheric turbulence. There is no surface to land on, only a descent into deeper and denser layers of gas until the crushing pressures obliterate anything that dares to enter. The destruction of WASP-12b offers more than spectacle. It offers lessons about the forces that govern planets and stars. The process by which the planet is losing its material is called Rochlobe overflow. Essentially, the planet has wandered too close to its star, into a region where the star's gravitational pull is stronger than the planet's ability to hold onto its own atmosphere. The gas streams outward, spilling into the star's grasp, as though the planet itself were bleeding into space. It is a cosmic example of overreach, of what happens when a world crosses boundaries that cannot be uncrossed. Astronomers have observed this transfer of matter using the Hubble Space Telescope and other instruments, detecting the signatures of hydrogen, helium, and heavier elements escaping into space. The planet is literally evaporating before our eyes. The story of WASP-12b also challenges our understanding of planetary systems. How did such a massive planet end up so close to its star? Gas giants typically form far out in their solar systems, where temperatures are cool enough for ice and gas to condense. For WASP-12b to orbit so near to its sun, it must have migrated inward after formation. Perhaps gravitational interactions with other planets or with the disk of gas from which the system was born dragged it inward, closer and closer until it reached the edge of survival. Now trapped in a death embrace with its star, it serves as a warning that not all planetary orbits are stable, and that the motions of the cosmos can place worlds on paths that lead only to destruction. What makes WASP-12b even more remarkable is that it reflects nearly no light. Most planets, even those close to their stars, reflect some of the starlight that hits them, but WASP-12b absorbs almost all of it, making it appear pitch black to telescopes. It is one of the darkest planets ever discovered. This eerie darkness may be due to its atmosphere, which at such high temperatures cannot form reflective clouds. Instead, light is swallowed by vaporized elements and complex molecules, turning the planet into an almost invisible phantom against the glare of its star. To the human imagination, it is as though the planet is cloaked in mourning for its own impending death, a shadowy figure being erased from existence. The violence of WASP-12b's environment also gives scientists a window into what happens when stars consume their planets. Eventually, many stars, including our Sun, will expand into red giants and engulf their inner planets. WASP-12b shows us this process in its early stages, giving us a laboratory for studying planetary death. Watching the gas streams, the deformed shape, and the gradual decay of its orbit helps us understand not only distant exoplanets, but also the future of our own solar system. One day, billions of years from now, Mercury and Venus will likely be consumed by our Sun, and Earth may share their fate. WASP-12b is a glimpse of that far-off destiny, but beyond the scientific insights, the story of WASP-12b resonates on a deeper, almost philosophical level. It reminds us that permanence is an illusion in the universe. Worlds are born, worlds evolve, and worlds can die. The Earth, with its lush forests, oceans, and civilizations, feels eternal to us because our lives are so short. Yet in cosmic terms, Earth too is temporary. WASP-12b is a vivid reminder of that truth, showing us in real time what it looks like when a planet is dismantled piece by piece. Its destruction is not sudden but gradual, a long surrender to the gravity of its star. To the human imagination, WASP-12b is almost mythological, a giant being devoured by an even greater force, powerless to resist. Its darkness, its deformation, its loss of atmosphere all paint the picture of a doomed world in the final chapters of its existence. It is dangerous not because we could ever live there, but because it demonstrates the raw, merciless power of cosmic mechanics. It is a world where survival is impossible, where existence itself is being stripped away. In a universe that often feels eternal and unchanging, WASP-12b is a reminder that everything has an end, even planets. For astronomers, observing WASP-12b is both heartbreaking and awe-inspiring. The instruments we use to measure its atmosphere, to track its orbit, and to watch its decay are like watching a patient in decline, every observation a record of the inevitable. Yet from that process we gain knowledge. We learn how atmospheres behave under extreme heat, how stars and planets interact at close range, and how systems evolve over time. Every piece of data helps us understand the broader universe, even as the planet itself moves toward annihilation. If one could somehow fly past WASP-12b, the sight would be surreal. The star would dominate the sky, immense and merciless. The planet itself would loom like a dark shadow, stretched and distorted, with streams of gas trailing away like wisps of smoke. There would be no solid ground, no place to stand, only an endless descent into layers of heat and pressure. The atmosphere would shimmer with exotic chemistry, clouds of vaporized metals mixing with hydrogen and helium, creating storms unlike anything we can imagine. And beyond it all, the quiet inevitability of destruction, the certainty that this world's days are numbered. In the great catalogue of dangerous planets, WASP-12b stands apart. Others may crush you with pressure, sear you with heat, or poison you with toxic gases, but WASP-12b does more. It dies before your eyes. It is a planet not only dangerous but doomed, a world whose danger lies in the very fact that it cannot survive. It is a reminder that in the cosmic scale, even giants fall, even planets perish, and that the universe is in constant motion, reshaping, consuming, and remaking itself. And perhaps that is why WASP-12b holds such power over our imagination. It is not simply a scientific curiosity, it is a story. The story of a planet that flew too close to its star, that lost the battle for survival, that is now being torn apart piece by piece. In its destruction, we find meaning. We see the fragility of worlds, the impermanence of existence, and the raw might of the universe. WASP-12b is dangerous, yes, but more than that, it is tragic, a silent warning that nothing in the cosmos lasts forever. When we look into the night sky and think about the countless planets orbiting stars across the galaxy, it is easy to get swept away by a sense of wonder. We imagine lush alien forests, glittering oceans under strange skies, and civilizations that might be thriving somewhere far beyond our reach. But as scientists continue to study exoplanets and our own solar system, what we see more often than not are worlds of danger, planets that seem bent on reminding us that life is fragile, rare, and easily undone. From the glass storms of HD 189,733b to the hellish furnace of Kelt 9b, from Jupiter's crushing depths to Venus's poisonous skies, from the slow death of WASP-12b to the countless frozen or barren planets scattered across the stars, the lesson is clear: Earth is not just our home, it is an extraordinary sanctuary. The dangers of other worlds reveal to us the extraordinary gift of balance we enjoy here, a gift that may be more precious than we can truly comprehend. Consider for a moment the wild variety of dangers planets present. Some worlds are destroyed by heat so fierce that molecules themselves are torn apart. Others freeze in perpetual night, their surfaces colder than any place on Earth could ever reach. Some are bombarded by deadly radiation from nearby stars, others suffocated under atmospheres so thick they would crush steel. Some are toxic with gases like methane, sulfur dioxide, or carbon monoxide, while others are stripped bare of any atmosphere at all, leaving them exposed to the relentless void of space. What all of these examples demonstrate is that habitability is not the rule of the universe, it is the exception. Life requires a very narrow range of conditions, and Earth just happens to provide them. The dangers of these planets also force us to face the truth about how delicate the balance really is. On Earth, we take for granted the idea that the air we breathe will always be there, that the oceans will always support us, that the climate will remain relatively stable. But looking at Venus shows us a cautionary tale. It is a planet roughly the same size as Earth, formed from the same material, orbiting in the same neighborhood of the solar system, and yet its surface is a blazing inferno with crushing pressure and clouds of acid. The greenhouse effect there spiraled out of control until life became impossible. For Earth, this is not simply an academic lesson. It is a warning. Our own atmosphere is vulnerable. Our climate is sensitive to the gases we put into it. If we tip the balance too far, we risk pushing ourselves down a road that cannot be reversed. Venus teaches us that even a planet that starts out similar to Earth can end up utterly hostile if its climate runs away. From Jupiter we learn another lesson, one of scale and force. It is the king of planets, massive enough to shape the architecture of our solar system. Its gravity has acted as both protector and predator. On one hand, Jupiter shields Earth by pulling in asteroids and comets that might otherwise strike us. On the other hand, it demonstrates that not all planets are meant to be habitable. Its crushing pressures, deadly radiation, and swirling storms show that giant worlds are not gentle places to live. They remind us that just because a planet exists does not mean it offers refuge. The forces of gravity, magnetism, and radiation are indifferent to life. If Earth were just a little closer to Jupiter, or if our orbit were slightly different, our world might have been bombarded into ruin long ago. Then there are the truly alien dangers, the kinds that stretch the imagination beyond what we are used to. On HD 189,733b, for instance, winds blow at thousands of kilometers per hour, carrying shards of glass that slice through the atmosphere like blades. To think of such a world is to realize how mild our hurricanes and storms truly are. On Kelt 9b, the very air is ripped apart by the heat, making it impossible for chemistry as we know it to exist. On WASP 12b, the danger is not only heat but death itself, as the planet is pulled apart and consumed by its star. These are not just worlds where humans cannot survive. They are worlds where existence itself is in the process of being dismantled. So why do these lessons matter? Why should we care about the fates of distant planets or the extreme conditions of worlds we will never set foot on? The answer is that they give us perspective. Earth feels permanent to us because our lives are short compared to planetary timescales. But the universe reminds us again and again that permanence is an illusion. Stars burn out, planets are consumed, atmospheres are lost, water evaporates, worlds collide. If we forget this, if we assume Earth's balance will always protect us, we risk arrogance. By studying dangerous planets, we remind ourselves that survival requires respect for the delicate equilibrium that makes our own world livable. These planets also expand our understanding of what is possible. For centuries, humans assumed that worlds beyond Earth would look similar to ours, with blue skies and green landscapes. Instead, what we are finding are planets stranger than fiction, boiling gas giants, dark planets that reflect no light, ice worlds with oceans hidden beneath frozen shells, and planets orbiting two suns. This diversity shows us that life, if it exists elsewhere, will have to be incredibly adaptable, and it highlights just how fortunate we are that Earth offers exactly what we need: liquid water, breathable air, moderate temperatures, a protective magnetic field, and a stable orbit. Even the smallest changes to these factors could have made Earth as uninhabitable as any of the dangerous planets we study. There is also a humbling element to these lessons. We like to think of ourselves as powerful, as masters of our planet, capable of bending nature to our will. But in the face of planetary forces, we are fragile. A shift in orbit, a burst of solar radiation, or an increase in greenhouse gases could all render our world hostile. Compared to the raw power of stars and planets, humanity is small. Dangerous worlds remind us that survival is not guaranteed. It is a privilege, and that privilege comes with responsibility. If we misuse Earth's resources, pollute its air and water, or destabilize its climate, we may find ourselves learning the same lessons that Venus did, only too late. At the same time, dangerous planets inspire us. They show us the limits of what nature can do, and in doing so, they challenge us to expand our understanding. Studying the atmospheres of hot Jupiters or the volcanic scars of Venus requires ingenuity. It forces us to develop new telescopes, new probes, new models of physics and chemistry. In this way, the dangers of other worlds push our science forward, helping us grow as explorers, and with each discovery, we gain a deeper appreciation for the miracle of Earth. Every photograph of a barren planet makes our forests seem greener. Every data point from a toxic atmosphere makes our air feel fresher. Every glimpse of a star-devoured world makes our own sun, steady and stable, seem like a gift. On a deeper, human level, these lessons also stir something within our imagination. Stories of doomed planets and hostile worlds have long fascinated us, from myths of fiery underworlds to modern science fiction. But what science is revealing now is that such places are not just fantasy. They are real, scattered across the cosmos. The mythic landscapes of destruction exist in physical form, teaching us that the universe is as much a place of danger as it is of beauty. And in those stories we find meaning. Dangerous planets are like cautionary tales written in the stars, urging us to appreciate, protect, and cherish the rare oasis we inhabit. When we think about Earth in this context, our planet becomes even more extraordinary. It is not simply a rocky body orbiting an average star. It is a masterpiece of balance, close enough to the sun to stay warm but not so close as to burn, shielded by a magnetic field that protects us from radiation, blessed with liquid water that cycles between ocean, sky, and land, enriched with just the right mix of gases to sustain life. It has seasons, weather, and ecosystems that support astonishing biodiversity. It has endured asteroid impacts, volcanic eruptions, and ice ages, and still it sustains us. No other planet we have yet studied offers this combination. None even comes close. Earth is rare not only in our solar system, but possibly in the galaxy. To forget that is to forget the lesson written across the dangerous worlds we study. Ultimately, exploring dangerous planets is not about running away from fear, but about confronting reality. The universe is not designed for us. Life exists only in narrow margins, and those margins can close quickly. Earth is not permanent. One day our sun will expand, our oceans will boil, and our atmosphere will be stripped away. But that day is billions of years away. Right now, we have the chance to live, to grow, to protect, and to understand. If we heed the lessons of dangerous worlds, we will treat Earth with the reverence it deserves. If we ignore those lessons, we risk pushing ourselves toward the same fate as Venus or WASP 12b. So when we gaze at the stars and think about the dangerous planets that orbit them, let us not see only alien threats. Let us see warnings, let us see reminders of how fragile life is and how precious our own world is. Let us see motivation to explore, to discover, and to protect. For in the end, the greatest lesson these hostile worlds teach us is not about them. It is about us. It is about Earth, about home, about the rare miracle of a planet that sustains life in a universe filled with danger, and perhaps that is the most important truth of all, that in the vast, unforgiving darkness, the very dangers of other worlds illuminate the priceless gift of our own.